Section 6.3 Modeling Linear Associations. Section 6.1 and 6.2, we talk about the linear association. We know how to construct a scatter plot and we know how to find the linear correlation coefficient R. For these sessions, we're going to talk more about it for the modeling linear associations. Look at this example. The mean ticket price for the top 50 grossing concert tours are sold in for various years. Let P be the mean ticket price in dollars at T years since 1995. Construct a scatter plot of the data. So look at the table here. We have the number of the years starting from 1998 to 2011. And we have the mean ticket price in dollars for each year in here. So my year will be my explanatory variable. And for Y here, this is going to be my response variable. Before we construct the scatter plot, since they already let P be the mean ticket price at T years since 1995, this means like T equal to 0 when the year 1995 in here. So think about it. What is T equal to when the year 1998? You could subtract in 1998 minus 1995, that would be the 3, right? So the T equal to 3 represent 1998. And for the 2001 minus 1995, you're going to find it out, the T equal to 6 in here. So before we construct the scatter plot, I want you guys to write the T in here. So you should have the chart in here. T equal to 3 represent year 1998. T equal to 6 represent the year 2001. And the mean ticket price, it doesn't change. You could just copy from here. Now, based on this table, I want you guys construct a scatter plot. Make sure your scatter plot have the title, label the x-axis, and label the y-axis. So you should have the pictures like this. The first coordinate, 333, so 333. 647, so 6 here, and then about $47. You have the title, label the x-axis, years since 1995, T equal to 0% 1995. So when T equal to 3, you're gonna add 3 from here, so that'll be 1998, which is gonna be this guy. Number 2, is there a linear association, a nonlinear association, or no association? So look at the scatter plot here. We could draw a line on the scatter plot, and you could see all those points is going to be around the straight line. So obviously there is a linear association. Number 3, compute the R. On the basis of the R and the scatter plot, determine the strength of the association. Remember how to find your R? I teach you guys how to use your calculator to find the R on the section 6.2. Let me show you guys one more time here. Okay, use your calculator. Click on the stat. Click on number 1 added. So I'm gonna input my X coordinate on my L1. So I have 3, enter, 6, enter, 9, enter, 13, enter, 16, enter. And then I'm gonna plug in my Y coordinate on my L2 here. So 33, enter, 47, enter, 59, enter, 67, enter, 85, enter. Okay, L1 represent your coordinate of X, L2 that will represent your coordinate of Y in here. You could see the coordinate 333, 333, 647, 647, 959, 959. Okay, now you're gonna click on the stat again. Use the arrow button, go to the right, go to the test, and then go up. You're gonna find the linear regression t-test. Okay, linear regression t-test. Enter. So my data is gonna be on L1. If you don't have this one, you could plug it in. You could see the L1 here. So you're gonna do second 1 for L1. Enter. Second 2 for L2. Enter. Frequency, just keep it as 1. And here, right now, you only need to plug into not equal to 0. We're gonna talk about this guy for the Math 227. Go to the calculate. Leave a blank for the regression equation and go to the calculate. Enter. Go down. You're gonna see the R equal to 0.98856. So we want the 2 decimal space. It's gonna be approximate 0.99. And because R is so close to 1, and because the points in the scatter plot appear to lie so close to a line, we conclude that the association is very strong. Remember, for the R, the linear correlation coefficients, R is always in between -1 to 1. And if your R close to the 1 or close to -1, that means the linear correlation is very, very strong. So R equal to 0.99, which is really close to 1. So we believe that the linear association is very strong here. Okay, number 4, draw a line that comes close to the points for the scatter plot. So we could just draw the straight line here around all these points. You don't have to pass through like all those points. You just need to find a line really, really close all the points in here. And actually, you could use the calculator to find out this equation. And we call this as a linear equation. For this class, I only need you guys know just approximate, draw a straight line around all those points in here. And we sketch a line that describes the mean ticket price situation. The process of choosing a line to represent the association between the time and the mean ticket price is an example of modeling. Okay, when we draw the line here, all the points close to this straight line, and we call this is the example of modeling. A model. A model is a mathematical description of an authentic situation. We say the description models the situation, and we focus on the linear model. A linear model is a non-vertical line that describes the association between two quantities in an authentic situation. We want to show these two variables are correlated to each other. If we could draw the straight line here and all the points close to this straight line, we say there is a linear correlation or linear association. Example, use the linear model so to estimate the mean ticket price in 2000. So we want to find out when the year 2000, what is the mean ticket price in here? Okay, remember, this is the years since 1995. This means when t equal to 0, represent 1995 in here. Right now, I want to find out the mean ticket price in 2000. So you could do the math, just use the 2000, subtract the 1995. You could get equal to 5. So that means when t equal to 5, represent the year 2000. So t equal to 5 is going to be here. Okay? We're going to draw the arrow from the 5 to hit the linear equations. And then we're going to go to the left. You could approximate what is the mean ticket price in 2000. At this point, we could say The p-coordinate of the point is 42. And according to the model, the mean ticket price in 2000 was approximate $42. And we could verify our work by checking the result is consistent with the value shown in the table below. So we have this table, and we are looking for the mean ticket price in 2000. So year 2000 is between 1998 and the 2001 in here. And right now we find the price is $42. And $42 is in between 33 to 47. Our answer should be make sense. The year 2000 between 1998 and 2001. So $42 is also in between $33 to the $47. Okay, try the number 2 example. Use the linear model to estimate the mean ticket price in 2010. So first, I want you guys figure out what is t equal to in year 2010. Do the math again. Use the 2010 minus 1995. So t equal to 15. T equal to 15 somewhere like here. Okay, then we go up, hit the linear equation, go to the left. So that is about like 79, right? $79. So we're gonna say the approximate mean ticket price in 2010 was $79. And again, double check your work. When is it 2010? Somewhere like here, right? In between 2008 and 2011. And you find $79. So $79 is also in between 67 to 85. So this is good. Okay, do the number 3. Use the model to estimate in which year the mean ticket price was $65. This time they given the mean ticket price, and I want you guys find out the year. So $65, like here, right? Draw the line from the 65, hit the linear equation, we're gonna go down. So it's approximate, that's a 11. Okay, so the t-coordinate of the point is gonna be 11. And again, you have to figure out what is the year when t equal to 11. So t equal to 0, that will be the year 1995. T equal to 11, you could just add up the 11 with the 1995 here, which is going to be 2006. So we will have the mean ticket price $65 in the year 2006. Again, double check for your work, $65. So it should be in between here, right? And then we found it out the year is 2006. So that's between 2004 and 2008. So this is going to be make sense. Okay, input and output. An input is a permit value of the explanatory variable that leads to at least one output, which is a permit value of the response variable. This is talking about the x variable and the y variable. And we call the x variable, the explanatory variable has an input. And your output will be your response variable. Okay, definition, model breakdown. When a model gives a prediction that does not make sense or an estimate that's not a good approximation, we say the model breakdown has occurred. So this is talking about, just look at like this example. When the year is 2010, means t equal to 15, we draw the line here. We use the linear equation to figure out what is the mean ticket price in here. However, the linear equations here, it may not be a good example for you to find out the output in here. So we say it may not be a good approximation. If this is not in good approximation, we say the model breakdown has occurred. Intercept. Intercept of a line. An intercept of a line is any point where the line and the axis of a coordinate system intersect. There are two types of intercept of line sketch. So this is talking about the x-intercept and y-intercept. X-intercept is talking about the linear equation hitting the x-axis in here. So if you want to find the x-intercept, you want to put y equal to 0. For the y-intercept, when your linear equation hit the y-axis in here, this point we call this as the y-intercept. If you want to find the y-intercept, you're gonna pick x equal to 0. Okay, so this is an opposite way. Find x-intercept, y equal to 0. Find y-intercept, x equal to 0. Or you could just look at your rectangular coordinate system here, finding out these 2 points. Example, finding intercept and coordinates. Find the x-intercept of the line. So when you want to find the x-intercept, you're gonna set y equal to 0. So y-axis is here, y equal to 0 is at this point. So we're gonna draw here, you're gonna find it out, the x-intercept will be -2. So the x-intercept is -2, 0. Okay, find the y-intercept. When you want to find the y-intercept, you're gonna set x equal to 0. So x-axis here, x equal to 0 at this point, and then you're gonna go up. You find the y-intercept here, and the coordinate will be 0 and 1. Okay, find y when x equal to 4. So x-axis, x equal to 4 is gonna be from this point here. So you go up, hit the line, go to the left, you're gonna see y equal to 3. So y equal to 3 when x equal to 4. Last one. Find x when y equal to -2. This is y-axis, y equal to -2 is gonna be here. And then we're gonna hit the line here, go up. X will be equal to -6. So x equal to -6 when y equal to -2. Okay, another example. The percentage of cell phone user who send or receive text message multiple times per day are chosen in for various age group. So we have the table in here, we have the age group and then the age used to represent the age group and also the percent in here. So you could just think about it, consider these two columns. The first column here, this is your explanatory variable, which is going to be happen on your x-axis. And the second column here, this is represent your response variable. It will be on your y-axis in here. So let P be the percentage of the cell phone user at age 8 years who send or receive text message multiple times per day. So P represents the percent in here. Draw a model that describes the association between A and P. So the A is talking about in here. And then the P represents the percent in here. So you have the coordinate 21 and 76. Second coordinate 29.5 and 63. So when you guys construct a scatter plot in here, make sure your scatter plot with the title, label the x-axis, which is going to be your age, and label the y-axis, it will be your percent. Okay, you should have the pictures like this here. So the first one, 2176. So x equal to 21 is the one somewhere like here, and that will be the 76. You have the first coordinate. Second one, 29.5 and 63. So 29.5 is really close to 30, like here, and then 63, like here. Okay, you just need to do it point by point to construct the scatter plot. And after that, you want to draw the model. Means you want to draw a straight line here. And this straight line should be all the points around it. And since this line that comes close to all the data points, so we believe there is a linear association. Okay, number 2, predict the percentage of 35-year-old cell phone user who send or receive text message multiple times per day. So look at the graph in here. Predict the percentage of 35 years old. 35 years old, somewhere like here. Look at the green color here. And go up, hit the linear equation. You're gonna see that's a 54. Okay, 54 here. So the p-coordinate of the point is 54. So 54% of 35 years old cell phone users send or receive text message multiple times per day. Number 3, find the p-intercept. What does it mean in this situation? So let's look at the picture here. When we want to find the p-intercept, we're gonna set a equal to 0. A equal to 0 is gonna be here. So this point, this is gonna be my p-intercept, 0 and 106. Okay, and what does it mean in this situation? According to the model, 106% of the newborns who use the cell phone send or receive the text message multiple times per day. What's wrong with it? First, we have a 106%. Remember, we only can have 100% at most. That is a misleading when you have the percentage more than 106%. Second, do you guys think the newborns who can use the cell phone to send or receive the text message? No, right? So remember we learned like the model breakdown, right? When we use the linear correlation to predict some information and it doesn't really make sense for it, we call this as the model breakdown. And model breakdown has occurred for 2 reasons. First, percentage cannot be larger than 100% in this situation. So we got 106%. Second, the newborns cannot send or receive text message. So something wrong with this one. Number 4, find the a-intercept. What does it mean in this situation? So a-intercept means when p equal to 0, so we have this point in here. The a-intercept is 71, 0. What does it mean in this situation? So according to the model, no 71 years old cell phone users send or receive text message multiple times per day. So again, this is another model breakdown has occurred because we may have some 71 years old cell phone user who send or receive text message. But here, they indicates that there's a no 71-year-old cell phone user send or receive the text message. So something wrong with this prediction. That's it for the session 6.3.